Since childhood, we've been fed one simple idea. Space is absolute silence, a vacuum, a place where no one can hear you scream, simply because sound waves have nothing to travel through. We looked up at the stars and thought it was an eternal, dead quiet. That is an illusion. Space isn't silent. It howls, grinds, and pulses. For decades, NASA probes have been capturing data on electromagnetic storms, radiation belts, and plasma vibrations. Scientists translated this dead data into the human auditory range, and it terrified them. Today, we are tearing off that safety filter. You will hear 7 real, official recordings from our solar system and deep space. What you are about to hear is absolutely real. We just chose not to listen. The Perseus galaxy cluster, 250 million light-years away from us. At its very center pulses a supermassive black hole. For a long time, astronomers were convinced it was just a mute gravitational sinkhole. But the Chandra X-ray observatory detected an anomaly. The black hole is surrounded by a colossal ocean of superheated gas. And that gas is rippling. The crushing pressure from the event horizon compresses the gas cloud. The black hole literally generates an acoustic wave. It's a continuous B-flat note, but it resonates 57 octaves below the limit of human hearing. To make it audible for you, NASA engineers compressed the data and pitched it up hundreds of quadrillions of times. You are listening to a sound that hasn't stopped for 2 billion years. This isn't just cosmic static. It's the groan of trillions of tons of matter being ground alive by gravity. It is the sound of the place where time itself dies. Saturn, the jewel of our system, if you look at it through an amateur telescope from a safe distance. But up close, it's a gas giant surrounded by ice shards and deadly radiation. In 2004, the Cassini spacecraft entered Saturn's orbit. It was a piece of cold metal sent by humanity into the absolute void to be our eyes and ears. Cassini's instruments began detecting intense radio emissions coming from the planet's poles. These were the sounds of Saturn's auroras. On Earth, an aurora is a beautiful optical phenomenon. On Saturn, it's a raging electromagnetic storm of colossal proportions, where charged particles from the Sun slam into the planet's massive magnetic field. When scientists converted these radio waves into sound, they heard something resembling air raid sirens from an old horror movie, or the screams of ghosts trapped in the ice. These eerie, gliding frequencies are direct proof of how alien and hostile the environment is, just 1.5 billion kilometers from our home. If Saturn sounds like a howling phantom, then Jupiter is uncontrollable. Primal rage. It is the largest planet in the solar system, the king of storms and radiation. As the Juno spacecraft approached Jupiter, it had to cross an invisible but deadly boundary, the bow shock. This is the place in space where the solar wind, racing at 1 million kilometers per hour, slams into Jupiter's magnetosphere at blistering speed. It's like water crashing against the bow of an icebreaker moving at full speed. But instead of water, it's plasma. And instead of a ship, it's a magnetic shield the size of several suns. The recording of this collision sounds like a sharp whip crack, dissolving into the deafening roar of turbines and grinding metal. This is the sound of pure, raw physics. At this moment, you realize that planets aren't just colorful marbles in a textbook. They are gigantic,
aggressive machines, grinding matter and energy on a scale beyond human comprehension. Against the backdrop of this cosmic hell, our Earth seems like a quiet, safe harbor, but this safety is deceptive. Our planet also sings in the dark, and this song can be just as terrifying as Jupiter's roar. Surrounding Earth are the Van Allen radiation belts, giant toruses of high-energy particles trapped by our magnetic field. This is our shield, saving us from being scorched by radiation. But inside this shield, a continuous, invisible war is raging. As plasma waves pass through these belts, they create radio emissions that scientists call chorus or Whistler mode waves. If you translate these waves into sound, you hear rhythmic chirping and whistling, as if flocks of radioactive birds are flying through space. It sounds mesmerizing, but each of these birds is a stream of killer electrons capable of piercing a satellite's hull and destroying any electronics. We live inside this chirping radiation cocoon, balancing every second between life on a green planet and death by solar radiation. Imagine a chunk of dead ice and rock, irregularly shaped, pitted with craters, and covered in eternal darkness. This is Comet Churyumov-Gerasimenko, or 67P. It hurtles through the gloom, hundreds of millions of kilometers from the Sun. In 2014, the Rosetta spacecraft approached it to do the impossible, land on its surface. But even before the landing, the spacecraft's magnetometer detected a strange phenomenon. The comet was singing. It was emitting low-frequency magnetic oscillations at around 40 to 50 millihertz. This is deeply below the threshold of human hearing. When the frequency was amplified 10,000 times, the world heard strange rhythmic clicking and chattering, like the sounds of a predatory insect. Scientists discovered that this sound is born from neutral gas and dust particles that the comet ejects into space. They are ionized by sunlight and engage in a complex interaction with the solar wind's magnetic field, making the space around the comet vibrate. It is the sound of a dead rock coming alive and breathing every time it gets close to the warmth of a star. But all these worlds, all these orbits, rings and asteroid belts exist only because of one colossal object at the center of it all: the Sun. We are used to seeing it as a warm, yellow circle in the sky. But in reality, it is a thermonuclear reactor of unimaginable power, an ocean of boiling plasma where temperatures reach millions of degrees. The Sun doesn't just burn, it vibrates. Convection currents of superheated gas constantly rise from the star's depths to its surface and sink back down, creating continuous acoustic waves inside the Sun. They bounce off the surface, making the entire star resonate like a colossal bell. Scientists compiled 40 years of observational data from the SDO Space Observatory and translated these pulsations into sound. It's a deep, low-frequency bass, the continuous heartbeat of a star. Listening to it, you physically feel the mass of this object. This is the sound of the force that holds our entire solar system together, keeping the planets from flying off into the pitch-black void of deep space. Where does this territory end? Where is the border of our home? In 1977, humanity launched the Voyager 1 probe. Aboard it is a golden record with Earth's coordinates, sounds of nature and music. It flew for decades, past the gas giants, and headed into the void. In 2012, Voyager 1 did what no man-made object had ever done. It left the heliosphere. It pierced the sun's magnetic bubble and entered interstellar space. There, in absolute cold and darkness, the probe's plasma wave detectors recorded a continuous rising hum. This is the sound of interstellar plasma, the sparse gas filling the space between the stars. This hum is nothing like the storms of Jupiter or the howling of Saturn. It is steady, monotonous, and terrifyingly calm. It is the voice of absolute emptiness, the sound of the place where the influence of our sun ends forever. Listening to this hum, you realize how small and alone this golden machine is, slowly drifting in the dark, and how fragile we all are, living on a speck of dust in a beam of light, while the boundless, cold, and indifferent universe rages around us. Space has never been silent. We've just been covering our ears for too long.